Hi Chem, today we're talking about water ionization, and that's going to build into acidic and basic solutions, which forms, most of this unit. We're done with Le Chatelier's principle, and it really only comes back for the test, but Kc sticks around, as you'll see. All right, so we're talking about water, and check this out. The second point there is that pure water is observed to have a very slight conductivity. I don't have access to my equipment, so I can't show you that, but it's true. Now, Arrhenius figured out that conductivity in solutions is caused by the presence of ions. Okay? So logically, if pure water has conductivity, it must have ions. But that's if only water's present. So let's figure out what's going on. Okay? Pure water spontaneously ionizes into hydronium and hydroxide. Now I want to mention, we're going to call hydronium H3O from now on. You may have seen that as H plus in the past, but H plus just bonds with the water, and this is much more accurate. So we're going to call that H3O. All right. So this is occurring in water at all times. It's an equilibrium system. Okay. Kc we can write, looks like that. However, I know you guys are sharp. Water's a liquid, so you don't actually include that term. Kc for water is just going to be hydronium times hydroxide. Okay, concentrations. Now, that has a special name. That's called the ionization constant for water, Kw. We're going to use Kw a whole lot. It's super useful, all right? Because we figured out that Kw equals this value at SATP, 1 times 10 to the negative 14. Okay? In pure water, the molar ratio is 1 to 1 for hydronium and hydroxide, which means they have to have equal concentrations. Okay? And I just took the square root of this because this times this has to equal that. If they're both equal, take the square root of that, you get this. So that's the concentration of hydroxide and hydronium in pure water, okay, which is fairly interesting. And in basic solutions, you just have more hydroxide than water, or a higher concentration, I should just say. In acidic solutions, you have a higher concentration of hydronium than water does. All right, and then the converse is true. In basic, you have less hydronium than this value. In acidic, you have less hydroxide than this value.